These two locks may look similar, but they use different types of keys. You might be more familiar with the key on the left. However, if you've recently bought a lock, the key on the right might be the same as your key. This lock is called a disc detainer lock, invented in 1907 by Emil Henriksson, the founder of Abloy. Because of this, some people refer to it as an Abloy lock. It's impressive that a mechanical device has lasted over 100 years and is still widely used today. But if you look at the lock on the left, the basic mechanism inside it dates back as far as 2000 BC, and it's also still in widespread use. This type of lock is called a pin tumbler lock. The disc detainer lock was developed in response to the pin tumbler lock's vulnerability to picking techniques. Before we dive into the mechanics of a disc detainer lock, let's take a look inside the pin tumbler lock to understand why it can be easy to pick. This part is called the shackle, typically made of steel alloy. There are locking notches on both sides of the shackle. Inside the body, two spring-loaded locking pawls hold the shackle in place when it's pushed down. The cylinder, located underneath the pawls, contains two sets of pins. When the correct key is inserted and the cylinder is rotated 90 degrees, it retracts the locking pawls, releasing the shackle. In some designs, steel balls are used instead of pawls to lock the shackle. These balls are driven by a cam on the cylinder. When the cam rotates to the unlocked position, it allows the balls to move inward, releasing the shackle. The purpose of the key is to rotate the cylinder, but only with the correct key. In a pin tumbler lock, this is done using driver pins that intersect with the cylinder, preventing it from rotating. Inside the cylinder, there's another set of pins called key pins, each with a different length. When the correct key is inserted, the key pins align with the notches on the key, creating a shear line with the driver pins at the edge of the cylinder. This allows the cylinder to rotate and unlock the shackle. If the wrong key is inserted, the pins will not align correctly, preventing the cylinder from rotating. The number of pins and the shape of the key can vary depending on the manufacturer, but the key must align the pins correctly to unlock the lock. This design is both ingenious and easy to manufacture, which is why pin tumbler locks are still widely used today. However, there are some downsides. Pin tumbler locks can be relatively easy to pick due to the tolerance between the parts. For example, when you apply tension to the cylinder using a tension wrench, one of the pins will be under more tension than the others. By feeling and lifting each pin with a lockpick, you can identify the one under tension, which is harder to lift. Once that pin is lifted, the tension is released, and the driver pin moves out of the cylinder, getting stuck outside the cylinder wall due to the slight turning of the cylinder. You then move on to the next pin, and by repeating this process, you can eventually pick the lock. There's an even easier way, using a tool called a wave rake, named for its wavy shape. Just like before, you apply turning force with a tension wrench, then move the wave rake back and forth inside the cylinder. This causes the pins to move up and down randomly until all the driver pins are released from the cylinder. Or, if the lock has enough space behind the pins, all the pins can be moved out of the cylinder by using this comb pick. Of course, not all locks have that vulnerability, but some still do. Finding the right tool makes all the difference when tackling any challenge. Whether it's understanding the mechanics of a lock or mastering complex subjects, having the right approach is key. And when it comes to learning, there's no better tool than Brilliant, today's sponsor. Brilliant is where you learn by doing, with thousands of interactive lessons in math, data analysis, programming, and AI. What I love about Brilliant is how it makes learning incredibly effective. They have this unique approach where they start with the basics and help you build your understanding from the ground up. Every lesson is interactive, filled with hands-on problem solving, so you're actually playing with concepts rather than just watching videos. And Brilliant doesn't just focus on memorization. It helps you develop critical thinking and problem-solving skills. For example, their math courses don't just teach you theory. They actually show you how to build and use formulas to solve real-world problems. I've found this incredibly helpful for understanding how math applies to business and everyday situations. So, if you want to unlock new skills and challenge your mind, you can try everything Brilliant has to offer for free for a full 30 days by visiting brilliant.org/Quasar-Ed or scanning the QR code on screen. Plus, you'll get 20% off an annual premium subscription. Now, let's look at the disc detainer lock. It also uses a cam and ball mechanism to lock the shackle. Unlike the pin tumbler lock, the cylinder is prevented from rotating by a sidebar, which partially sits in a groove outside the cylinder. The cylinder is more like a shell with two cut sections, and this narrow cut line usually aligns with the sidebar. Inside the cylindrical shell, there are stacks of discs with a keyhole in the center. In the locked position, the sidebar fits between the cut line, preventing the cylinder from rotating. Looking at the stack of discs, we see two types: those with rectangular holes, called drive discs, and those between them, called spacer discs. Drive discs have small extrusions that allow the disc to rotate 90 degrees inside the cylinder. They also contain notches or gates. And when the correct key is inserted and rotated 90 degrees, all the notches align with the sidebar. Continuing to rotate the key causes some extrusions to push against the cylinder edge, which in turn pushes the sidebar into the notches, allowing the cylinder to rotate. The cam's rotation then moves the balls inward, unlocking the shackle. Unlike the pin tumbler lock, the key cannot be removed after opening the lock. To remove the key, the lock must be closed because the rectangular holes in the discs only align in the locked position. In that position, the notches are misaligned with the sidebar and are in random positions. The key is cut to match each disc's notch position. If you look at the key, there are uncut sections between the cuts. The discs corresponding to these uncut sections rotate fully with the key, aligning their gates at 90 degrees. The other discs, which align with the cut sections, only start to rotate after a certain angle, depending on the depth of the cut. The key can't be removed because of these discs blocking the uncut sections. When the key is rotated 90 degrees, the gates align with the sidebar. If you continue rotating, the limit notches push the cylinder, and since the sidebar is aligned, it moves into the gates, allowing the cylinder to rotate further and unlock the lock. To relock, you rotate the key in the opposite direction. Since the sidebar is already inside the gates, it pushes the cylinder until it aligns with the outside groove. At this stage, the cylinder cannot rotate further due to the limit pin on the top, so the rotation of the discs pushes the sidebar out of the gates and into the groove, locking the cylinder in place. The discs aligned with the uncut sections of the key rotate fully, while those aligned with the cut sections rotate according to the depth of the cuts, eventually aligning so the key can be removed. A locking pin above the cylinder limits the cam's rotation to 90 degrees back and forth, ensuring that the sidebar always ends up in the groove when locked. However, disc detainer locks can also be picked, but it's much more difficult than with pin tumbler locks. A specialized tool like this one is needed to pick a disc detainer lock. This tool has two concentric shafts. The outer shaft applies torque to the cylinder and the sidebar, while the inner shaft rotates each disc. The inner shaft can be moved along its axis to pick each disc individually. Like with any picking technique, the discs are rotated, feeling for tension or listening for clicks until all the gates are aligned. In more secure disc detainer locks, there are additional shallow notches on the discs called false gates, making picking much more difficult. High-end pin tumbler locks use a similar concept with spool pins. These pins have extra edges, making it difficult for a lockpicker to tell if a pin has been fully released or just caught on an edge. However, if the pin is pushed further, the transition from the narrow to the wider section causes a slight counter-rotation of the cylinder. By sensing these counter-rotations, the lock can still be picked. Another important factor in locks is tolerance. In a pin tumbler lock, if the pins and holes fit perfectly with tight tolerances and stronger springs, picking the lock would be much more difficult, if not impossible. However, achieving such precision is often not cost-effective for mass-produced locks. Even in disc detainer locks, low tolerance in the gates and balls can make them easier to pick or break. So, depending on what you need to secure, it's crucial to choose the right type of lock carefully. No matter how secure a lock is, there are always those who challenge its security and find flaws. Then someone invents a more secure lock, and the cycle continues. This feedback loop drives our society to constantly improve. So why not just use more secure locks, like disc detainer locks, instead of pin tumbler locks? One reason is that most people aren't aware of which type is more secure, and the likelihood of having your lock picked is actually very low. We also share a collective belief that if something is locked, it shouldn't be broken. That's why we use a variety of locks, regardless of which one is more secure. For those determined to break in, any lock can be defeated, even with just a hammer. But that isn't necessarily a bad thing, because if we ever lose our keys, we might be the ones swinging that hammer. Interested in learning how other types of locks work? Leave a comment. Thank you for watching, and see you in the next video.